All right, let's get back into this. Actually, I noticed that the time that it's going to take to complete some of these has gotten it's gotten longer. So this should be a lot of reading, I feel like. All right, so word count. Sometimes you'll need to count the number of lines, words, or even characters in a text file. Why, you ask? Well, you don't want to go over the allocated word limit for that document you're writing. The WC word count command is a tool predominantly used for counting different elements of a file. Yeah, that's pretty good. I usually use it to count the number of files, but yeah. Using the WC command, by default, entering the command line WC file name will count the number of lines, words, and characters in a file and output the results to your terminal in that order. So you get lines, words, characters. For example, entering command WC my log file might result in lines, words, characters. All right. This tells us that in my log file there are 145 lines, right. Additional parameters. It's possible to filter out the output of the WC command and only print the number of specific elements in the file. For example, adding the -w parameter would only output the number of words in the file. Similarly, L is for lines, right? To see all the possible options, just use help. All right, let's do that. Let's look at all the options. I'm using Control L, by the way, to clear the screen. WC help. What do we got? We got bytes, characters. That's confusing. Lines. All right. Let's see. And I'll actually, let me do this. I'll show you a little trick that I like to do. Basically, counting everything in here with an exec flag. So WCL, we're going to count the number of lines. And so this counts each file that goes into it, into the brackets. Close that. And of course, I didn't do it right. So what didn't I do right? Interesting. Are we supposed to do like type file? Invalid option T. Dude. What is going on? This is why I love getting into this. File type F. All right, there we go. Nice little embarrassing moment. And then you could kind of sort it, you know. Anyway, I like that. So navigate to the Clever Counting directory. Okay. Use the WC tool to count the number of lines in the lorem file. Lorem, using the /L. Got 20 lines. 20 lines. Use the WC tool to count the number of words in the lorem file. WC words. I think you could do words. Let me actually see. Yeah. All right. WC words. I like doing this because then you know what you're actually doing the flag for. So we got 165. All right. Use the WC tool to count the number of lines, characters, and words in the lorem file. What number do you get if you add these numbers together? All right. We got, I think we could just do this. All right. So I wonder if we could do like a something like this, right? Let's see if we can do something like that. That would be pretty cool. This would be pretty cool. We got lorem, WCL lorem, WC C lorem. Nope, can't do that. Is it because these are strings or what? Let me actually try one of these. Oh! Trying to do Control W to move back. Oh shoot, we lost it. Well, now you know not to use it. So Control W removes the last word. CD clever counting. Let's just get lorem in. Yeah, I wonder how I could have added those, but I guess we'll figure that out another time. Again, I'm just learning here, so can we actually just use Linux as a calculator? 165 plus 1136. Damn. Can we do, like, is there a math function or something? You know what? Let's check this out. Linux, how to add numbers. Expression. I don't want the shell script. I just want to put it in the command. I feel like there's got to be an easier way. How do I add some command? Is there a some command? I guess there is. Wait. Some checksum block counts. That's not right. I guess we're using expression. That's so weird. Oh yeah, because bash uses for numeric. Right. Okay, so the way it works is this is variable expansion, and then this is arithmetic, or this is arithmetic. So if I do WC, if I do just 2 plus 5, it's going to add it up, right? So if I do WCL lorem, and then WC W lorem, and then actually I gotta do like, this is a lot of work for a couple of numbers, but hey, let's try to do this. Because these are like expansions. Sorry, one time. Add these strings here. And in here it's going to be, so then we're going to add one of these bad boys, WCC lorem. Why do I keep doing that? That's why bash is a little confusing, but let's see what we got. Oh man, missing a double quote here, right? Just in a double quote. Bad substitution. Bad substitution. I wonder why. Okay. WCL lorem. It's supposed to be like, okay. So how do you do that without adding it to a variable? That's what I want to know. Because I don't want to do this like lines equals WCL lorem, words equals WCW lorem, and chars equals WCC lorem. And then I got to do like a echo lines, right? And I get 20 lorem. Oh, that's probably why it didn't add. I didn't realize that. All right. All right, so let's do, I can't believe, it's got to be easier than that to add numbers. I guess we could just do this, right? EXPR. What do we have? What was the number? WC lorem EXPR 20 plus 165 plus 1136. There we go. All right. Jeez. Alrighty. Next. I'm gonna move. That was a while, but hey man, I'm just recording this so I can learn. So let's move on to the next one. What is the next one actually? Got manipulating text, stream redirection. Okay, let's see what we can do with manipulating text. 26 minutes is a long time. I'm already 12 minutes in. Bam, that's a lot of stuff. All right, manipulating text. You know how to edit files in text editors using the command line, right? But these editors aren't the most efficient way to take multiple edits at once. For that, the tools TR, translate, and sed, stream editor, I think, are incredibly useful. Translate is TR. You can use the translate command to manipulate text without needing to make multiple changes manually. Think of the find and replace feature in a Word document. TR takes input and replaces all instances of a specific string with another. With the command TR, original string to replace. So it's like search and replace kind of thing. For example, the TR-AB would replace every letter A with every letter B. If you entered the command TR-AB in your terminal, it would look like nothing is happening. This is because TR waits for input from the terminal to perform its replacement by default. If we wanted to make TR act on a file, we would need to use redirection operators, the less than and greater. I feel like a lot is going on here right now. They just mashed a lot into one thing, but all right. By adding the redirection, this is the stream input, to our original TR-AB command, TR would perform any replacement on the file's content rather than wait for input from the command line. You can also add the stream output redirection to the command if you'd rather the output be saved directly to a file than output the results to the terminal. Right. If we put all that together, the command TR-AB, so basically it comes out of here into TR, TR replaces any A with B, and then it goes into the new file. We take the contents of the myfile.txt, replace every letter A with a letter B, save the results to a file called newfile.txt. If the file exists, overwrite it. All right. For example, you may have a file in which you need to convert every lowercase into uppercase. Instead of writing ABCD, you could use the sets lower and upper in the command, right? And actually, TR has a pretty long command page. And it took me a second to figure out the sets thing. The sets are here. So you got like a bunch of stuff here. But you could also do A-C. Here's some other useful character groupings. Yeah, pretty good. You can also use TR to remove character sets from a file. Use the command trd character to remove the character set. Let's see what that does. trd delete. Makes sense. All right, before we move on to sed, let's do this. I'm actually, do we even go over grep? That's pretty interesting how they structured this. All right, that's very interesting. All right, let's get into this thing. So clear this up. Using the trd command, remove the punctuation from the quotes file. Let's do quotes. TRD punctuation from the quotes. There's a set called punctuation, right? Let's see where we are. Punct. All right. Punct. What's the name of it? Quotes. You know what I'm going to do? Yeah, there we go. All right, so now, and then if we do quotes otherwise, we got the quotes there, so you can see we're removing that stuff. What is the token you received for completing that successfully? Did we get a token? Oh, save the output. I didn't save the output. Okay. No punct. Boom. Pretty easy. All right. Not bad. Not going to get cocky, though. You see me struggle. All right. Using the tr command, convert lowercase characters in the quotes file to uppercase. Save the output as upper. All right. Pretty good. So tr lower. Change it to upper. We're doing quotes, and we're doing sending it to upper. All right, very cool. Very cool. Using TR, replace the curly brackets. Replace the curly brackets with the square brackets. Save the output of this command to a new file called brackets. All right. Is there like a, because I don't remember. All right, I think we're just going to have to do tr. I don't know, like, I think it's going to be like this, or I gotta maybe escape it. Maybe I gotta escape it. Yeah. Wait, do I need to escape the second one? That's the question. Quotes, brackets. Nice. Let's see, actually, let's do this. Yeah, got rid of it. So basically what we did was these are like two different strings, right? Two different characters. So it's either this or that. So it's going to replace anything in here. Like this is basically a set, right? Like it could be A, B, C, and it would be replace any of these or all of these. But these are kind of special, so you have to escape them. And I don't know where I learned that, but let's try. Let's see. Let's do this. Let's try without that. Let's do it like this so we can actually read it. Interesting. So I guess you don't need the escape characters. That's great. All right. Cool. Maybe that's regex. I don't know. Which of these is not a valid TR grouping? I have no idea. I really have no idea. Let's see what we got. We got alpha. I guess beta is not the one. I don't even know what that would be. Beta. Beta doesn't make sense. Sed. Stream editor? I don't know. Yeah, stream editor. Okay, stream editor. All right, now don't click this yet because they're just going to get us out. So the sed command is commonly used to search and replace specific string patterns from text. Unlike tr, sed can search and replace more specific strings rather than simply converting all instances of a character in the text. A typical sed command is constructed like this. S, pattern to find, pattern to replace, G. G is global, right? Opens the file, so broken down, it opens the file with error, looks for the string pattern to find. In the text file, if it finds any, replaces the string with pattern to replace, or it replaces this string with, wait a second, with the string pattern to replace. Yeah, it replaces this one that it found with this one, prints the result to the string. The thing that they're not going over is G, is that it's global. I don't really know how we got to sed. Like, I feel like that is a big leap. I guess we're supposed to study outside of this stuff too, because typically I think you're supposed to learn grep and then sed and then awk. Because this actually would take longer to spend time on than tr. And I feel like it gets used more than tr, so I'm kind of, all right. If, for example, you wanted to capitalize all instances of a name Alice in the file, sed would be advantageous over tr. Tr could replace all lowercase a characters with the uppercase equivalent, but this would also convert characters you don't want to convert. The command sed Alice and Alice global would instead be used. Yeah. Okay. Commands overview. Yeah, let's do this. Let's do q and sed. So what do we got here? Where's the global part? G. Copy, append, hold space to pattern space. Is it the end one? Let's see here. Sed G. This is G do with command sed. Here we go. Global modifier. In this context, at the end of the pattern is a flag preceding expression in program, means global replace. So like otherwise it replaces the first one, this one replaces all of them. Make the substitution for all non-overlapping. Why can't I find that here? Make the substitution for, like, where is it in the manual page? All right, let's do this. Man help. That didn't do much. G. I don't know. All right, onwards and outwards. Using the sed command, replace cake with the correct word and in the poem file. Poem file. Oh, we're supposed to do this here. Is there a poem file here? Yes, there it is. I can't paste it. Okay. Set S cake and G. Oh. New file. Correct. Oh. Boom. All right. All right, that was pretty good. That was pretty good. What else we got? Manipulating text, stream redirection, which we kind of did. You know what? I'm going to do that one only because I feel like it belongs to, like, should be part of this. And then the next video I'll do sudo. So let's do that. All right. Here we go, another long one. All right. Programs execute in the Linux command line across 3 data streams, which can be summed up as handling terminal input, terminal output, and any errors that should be displayed on the terminal. So we got standard in, which comes into the terminal, standard out, normal application out, standard error, any errors generated by the application. And an error would be like, you know, cat hello world, right? So that's an error. Okay, we'll go over this, right? Standard in, the standard in stream describes any input given to an application on the terminal. For example, if running cat myfile, the contents of the file myfile is considered to be the inputs. It is also possible to pass files as input using this character, the redirection. For example, the command tr uses the contents of the file as a standard in. Yeah, the only thing I'm wondering is if we could do like this. Let me do cat ls2. Yep, so it's the same thing because you're putting the file. Let's do ls cat ls. Same thing. There we go. All right, standard output, standard error. Standard out and standard error streams both handle the output generated by an application. While standard out deals with the normal output, assuming the application has behaved as expected, standard error is concerned with any errors coming out of there, which we just saw. Stream redirection. There are several. Wait a minute. Run the whoami command. Okay, nice. Whoami. To see its output on the terminal. Now run the command again, but redirect the output to a new file called alias. Whoami. So this is going into standard out. Alias. All right. Alrighty. And actually a cool one is like this, right? You do echo, or, sorry, what was the one? I'm trying to think. There was one where you could just continue to do, I don't know which one it was. Anyway, run the pwd command to see its output on the terminal, right? Print working directory. Now run the command again, appending the output to the file called existing. Existing. All right, let's go over that actually. Stream redirection. So there are several times where you may wish to redirect these streams and save them in different locations rather than just being output on the terminal. The redirection character can be used to save the output of a command to a file. However, adding a second one will instead append the output to an existing file. Adding the output to the bottom of what already exists in the file. For example, running the command lslist would run the command ls. And instead of outputting the results to the terminal, save the results into the file list. If the file already exists, it will be overwritten. However, if you were to enter this command, it will append it instead. Yeah, and there's actually another way. Let me see, I forgot what it was. I got it from this one, where you could do, it's not the -i that you do like with CP, but it would, let me see here. It would protect it from being overwritten, I believe. Now see, I'm not going to find it here. It's probably in the stream. Stream out. Stream out. There it is. Is there a way to not overwrite this? That's the question. I think that I set something. I actually forgot. I definitely did set something, but I forgot what it was. There is a way to set it so that it doesn't overwrite. Linux, how to set redirection to not overwrite. Shoot, definitely had a way to do that. There was a way to do that. Redirection, not overwriting file, but just producing. Prevent overwriting. That's what we want. No clobber. Yes, that's what I did. Let's see if that works. There's no way I was going to remember that. But let's see if this works. Set no clobber. Let's see if this works. All right. So cat existing. Okay, cat alias. Yeah. Now let's do echo hello alias. Boom. Cannot overwrite existing file. But I forgot how to like overwrite that. Like how to be about. Oh, this is it. That's it. Right. So now if we do and, we're good. Ah, nope. Jump the gun there. All right. No clobber. How to? Oh, actually, let's use the man page. Man no clobber or man set. Wait, right. Man no clobber. All right, that's going to be an interesting one. So now we can't overwrite it. No clobber option. Set built-in, no clobber. Is it just going to be like clobber? Clobber. Redirection. Clobber set where it exists. Oh, this is it. That's it. Let's do this. Boom. Cat alias, and we're good. All right. That's one to remember. Alrighty. Run the pwd command to see its output on the terminal. Now run the command again, appending it to existing without overwriting its contents. Right. Okay. Run the program output program. What? Run the program output program to see its output on the terminal. Oh. Now we'll run the program output program again, but redirect the standard out stream to a file called standard out. Alrighty. Nice. Very nice collecting tokens. Run the program error program. Is it gonna stream descriptors? Yeah, let's go over this first because that's important. Okay. Stream file descriptors, as seen in the image above, each stream has an associated file descriptor number. 0 for standard in, 1 for standard out, standard error is 2. These can be leveraged directly to control which screen you wish to redirect. This way, you can explicitly direct just a standard out stream or just a standard error stream. This can be useful when you want to ignore errors or capture them as part of a log file without printing them directly to the screen. To use the file descriptor, simply append the file descriptor number before the output stream, before the redirection character as shown below the output. You can direct each stream to a different file. Okay, now this I did not know. That's very cool. Some program to here. It's like a chain. That's cool. All right. That's very cool. All right, let's do that. Run the program. Program error to see its output on the terminal. Got it. Now run the program error program again, but redirect the standard error. Remember that's 2 to a new file called error. Okay, that's great. What am I missing here? Oh, I always do that wrong. Ah, man. Boom. There you go. And actually, you can, before I put that in here, you can ignore it. Like, so if I do program error to dev null, it like ignores it. If I do program error to, I think it actually, I actually don't know how to do it to echo. I feel like to echo, is that possible? Nope. How do you, Linux, how do you print standard error? Let me go back here. What did I miss here? And 1. What does that do? Redirect them into the other to combine the 2 streams using. Okay, that's probably it, right? Program error. Let's redirect standard error into output. That doesn't look right. It does not look right. So let me reread this. You can direct each stream into a different file if both are included, and you can even redirect one stream into the other to combine the 2 streams. Okay, pretty good. I feel like this is probably the most important lesson here, like the streams. But yeah, I'm gonna end this here. I think we're good.